Hello everyone, my name is Logan and welcome back to the lecture hall. For today's video we are covering what are exponential functions. So let us say that b is greater than 1. Well, our exponential function will look like f of x is equal to b to the x power, and it will follow a steep curve. It always intersects, no matter what b is, it always intersects the point 0, 1, and then it will always be at 1 comma b and then 2 comma b squared, because b to the x, well, depending on what x is, that's just b times blah 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 times b x many times, right? And so that's an exponential function. Now, what would our curve look like if b was actually less than 1? Well, our function would look something like this. Because let's say b was 1/2, well, it makes sense as we take powers of 1/2, they get smaller and smaller and smaller, right? And so we can see that if b is less than 1/2, let's just say that's 1 over b to the x, and then this would just be b to the x, right? Now we have our laws for our exponential functions, and so we need to set some stuff up first. We want a and b to be greater than 0, so positive numbers, and we need x and y to be in our real numbers. So let's see it. Well, b to the x times b to the y is actually going to be equal to b times x plus y. And this should make sense because it's just x many b's and y many b's, and when we put them together, it's x plus y many b's. Then we have b to the negative x. This equals 1 over b to the x. So that will help us with this one, our third one, that states b to the x over b to the y is equal to b to the x minus y. And that should make sense because 1 over b to the y is b to the negative y. Then we have b to the x power to the y power. This is in fact going to be b to the x times y, and this should make sense because we have x many b's, y many times, so then x many b's to the y many times, well, that would be x times y many b's. And then we have a times b to the x power. Well, that's just going to be a to the x times b to the x. And all this is saying is that we distribute our exponents to each term. The final thing I wanted to cover in today's video is e. E? Eulers Constant. So what is e? Well, e is approximately 2.71828. But e as a definition of a limit, which we will see in a few videos, I'm just trying to show this as a little teaser. E is actually equal to the limit as n approaches infinity of 1 plus 1 over n to the nth power. And we're like, cool, whatever that means. Well, we don't need to know right this second, but we really like e because its tangent line at x equals 0 is going to be actually equal to y equals x. So that's really cool. We'll get into tangent lines soon. And we also just have e, we really like e because e to the x is differentiable and equal to itself. So e is a very important number. We're going to see a lot of it, so memorize this, remember the approximation if you ever need to, like write it down on a test and you're not allowed to have a calculator. And yeah, so that's everything I wanted to cover in today's video. Another quick one. We know exponential functions. I just wanted to go over the laws. And yeah, as always, my name's Logan. Thanks for watching. Have a great day.